and this is a constant. It's a known value, but there are a few H pluses and OH minuses, and which is 10 to the 9 minus 11 molar. It's that simple. Well, it is a logarithmic scale, and it is based on the concentration of the hydrogen ion. Remember what acids do. Acids give up H pluses. And so the more concentrated the H plus, the stronger the acid and the lower the pH. Okay, so every jump between numbers on the pH scale, for example, the distance between a 3 and a 2 is 10 times the concentration of the H plus ion. Okay, so it ranges from 0 all the way up to 14. All right, and so remember, this is the greater the ion concentration. This is a high H plus concentration, and then we get down to a pH of 14. We basically have very few H pluses. All right, so this is a relationship in aqueous solutions where H plus and hydroxide concentrations are related. Remember, hydrogen, that has to do with acids, and then hydroxide has to do with bases. So let's take a look at water. And what happens to water is what we call self-ionization. So water liquid, that molecule, sometimes will bump into another water molecule. Remember, this is the slightly negative end, this is the slightly positive end. And so this one would attract the negative end of another water molecule, and actually one of those H pluses would come off. And so we make what's called the hydronium ion, and that is basically water with an H plus stuck onto the oxygen end. And then of course what's left over, once you remove that H plus, we have hydroxide. Okay, so this is called the self-ionization of water. And this is equilibrium, and if we were to write the equilibrium constant expression, we would have the hydronium ion concentration times the hydroxide ion concentration. And then nothing would be on the bottom of this expression because water is a liquid here. And so this is what we call the Kw for water. And this is a constant. It's a known value. At 25 degrees, this happens to be 1 times 10 to the negative 14th. And so in solution, mostly we're going to have water. Okay, in a glass of water, it's mostly water molecules, but there are a few H pluses and OH minuses, and those concentrations multiplied together will give you a tiny number, 1 times 10 to the negative 14th. And this happens to be the basis for the whole pH system. And so when you take the pH, it is a log of that expression. And so all of these formulas are derived from that mathematically. So if we take the log, the negative log of something, we call that taking the P, right? And so the pH, it's a definition. It's based on the hydrogen ion concentration. And then similarly, the POH, which you've probably never heard of, is based on the hydroxide concentration. So on your calculator, you should have an LOG button, which is just what power of 10 is that number. Okay, the good news is you're going to use your calculator, and these calculations are simple. But I really want you to see this equation right here. The pH plus the POH, those are going to be basically whole numbers, add up to 14. And the reason is the concentrations multiplied together give you 10 to the minus 14th. Now, this is way simpler than you think. Let's do a couple examples. All right, the first one I want to give you is we have a hydrogen ion concentration of 0.001, which is 10 to the negative third molar. Okay, this is just a hypothetical solution. So if we take the negative log of that, negative log of 10 to the minus third, well, the log of 10 to the minus third is negative 3, so this is equal to 3. It's that easy. The POH is 14 minus 3, which is 11. And then this concentration, we're going to raise 10 to the negative POH, which is 10 to the minus 11 molar. It's that simple. Okay, so notice that these two concentrations are going to multiply together and give you 10 to the minus 14th. Let's do another one. I like this box method, by the way. I think it makes it really neat and clean. All right, let me give you one here. We've got a pH of 4. All right, let's go. The pOH is 14 minus 4, 10. This one is 10 to the minus pOH. And then this one is 10 to the minus pH. That simple. All right, what if we don't have whole numbers? We can handle this. This happens to be a titration that I did. I've got a pH of 12.38. Really, really high, right? So this is going to be very concentrated in hydroxide. Let's go get the easy one. The pOH is 14 minus that, 1.64. Remember, they add up to 14. Now, how do we get the hydrogen ion concentration? 10 raised to the negative 12.38. Do that in your calculator. 10 caret, okay? Caret looks like this. Negative 12.38, and you're going to get a number. We can't leave it like this. 4.37, 10 to the minus 13th molar. Super small number. Now, let's look at sig figs right here. I want to take these two values. I'm going to actually go with a 4.4. So those are my sig figs, 4.4, 10 to the minus 13th. Okay, and then coming on down here to the hydroxide concentration, 10 to the negative 1.64 is going to be 2.3 times 10 to the negative 2 molar. Very concentrated, right? This is basic. Let me show you sig figs. Those two digits right there. Okay, sig figs are a little bit different. The number in front of the decimal is really going to be close to your exponent. Okay, so that is a little example of pH calculations. Don't be afraid of them. You've got the calculations. Just remember these are your formulas. And then a couple practice, you'll be good as gold on those.